how we achieve centimeter accuracy with a drone. I was trying to do some research myself, and it's a lot more complicated than, say, a setting on your phone or a setting on your drone.
It still feels like magic to me, but I feel like I know a couple of the spells, and that's really all you need to get the benefits of it.
Hello and welcome back to another episode of Your Drone Questions Answered. I'm John Dickow, here to find the answers to your drone questions, or at the very least, the person who can answer your drone questions. Today I have with me Greg Gradwell. He is a software engineer at Pyka. Greg, thank you for joining me today.
Yeah, thanks for having me. So I'm an aerospace engineer kind of by trade. I've slowly worked myself into the software space just because I wanted to work on autopilots and more autonomous features with aircraft. So I'm a software engineer at Pyka. I also work a great deal on kind of the hardware and writing firmware, which is how I ended up in the GPS and RTK centimeter level accuracy area, because we've added that to our aircraft.
Can you first just kind of tell me what centimeter level accuracy is when it comes to drones?
So the typical, just like a regular GPS kind of off the shelf, you'll get maybe 1 to 2 meters of accuracy in the horizontal, and maybe upwards of 10 meters in accuracy in the vertical, where they're less accurate in the vertical. So for some applications, that's just insufficient. So, the nice thing is a lot of inertial navigation systems will, be calculating a position that's more accurate than just the raw GPS, incorporating accelerometers and gyroscopes and other sensors to kind of fuse those all together and give you a better picture than just the raw GPS. But if you really need to know where you are, there are some other methods for getting, so like centimeter level accuracy is kind of like the tagline for about as good as you can expect with other methods.
I can imagine that can be pretty useful in certain industries. Give me some examples of how centimeter accuracy is used.
Surveying, if you are, taking like want to do a 3D scan, so you're using LiDAR. So it's very important to know exactly where your drone was at the time of every scan, because you're trying to, you can imagine if you're off by, let's say, even a meter, and you're projecting a beam of light, several hundred meters, that turns into a much larger error. Or, so that's a big one is 3D scans, or precision agriculture as well. If you have, let's say, a ground vehicle and you want to be spraying a crop, and you need to know exactly which row you're in. So if you're a meter off, you might be in a completely different row of your crop. So you want to really know exactly where you are. And yeah, generally, if you know within a centimeter, that's pretty good for most applications.
Yeah, no, absolutely. And when it comes to agriculture, I believe you at Pyka, you're doing work actually leading those type of projects for the agricultural industry. Is that right?
Yeah, exactly. So, we're developing autonomous crop spraying aircraft, as well as cargo aircraft. So in the air, the centimeter level accuracy is less needed. Because of course, like with an aerial application, we're talking about on the order of several meters that are a swath width of what we're spraying. But it's nice. I think one of the main advantages we found is we're in countries other than the U.S. where GPS is just not as good, and we were seeing even more accuracy bounds. And so our RTK really helped us bring that in and made our especially in takeoff and landing. Like we want to know exactly where we are, so we're on the runway every single time. So anything we can do to improve our solution is beneficial in many areas.
Very cool. Very cool. Yeah. And so kind of getting to the core of the question, how we achieve centimeter accuracy with a drone, I was trying to do some research myself, and it's a lot more complicated than, say, a setting on your phone or a setting on your drone. It's pretty involved, and you mentioned things like RTK. And so go ahead, kind of explain to me how centimeter level accuracy is achieved.
The reason we can only get 1 to 2 meters, of accuracy for just a traditional GPS is that, so we're getting essentially signals, radio waves from satellites in space, and those radio waves are traveling through the atmosphere. And I think particularly the ionosphere provides the most kind of disturbance, and the timing is very important for those waves. So if they don't have this direct path, then your receiver can't know exactly how long it took to get from the satellite to your receiver, and that's basically how we're calculating how the GPS is calculating its position. So what we need to do after the fact, what we're able to do is, if we know where the satellites were at the time that they sent those signals, we can either kind of compute some of the errors or remove some of the errors in real time, which is RTK, so that stands for real time kinematic, or we can do it even better after the fact, which is PPK or post processed kinematic. So if you're doing like a scan, let's say you want to have like a 3D scan of an area, PPK might be perfectly sufficient, where you fly without any sort of augmented GPS. But then after the fact, you can, from some sort of service, can know exactly where the satellites were. They can do this post processing and then kind of correct all of your positions to a much more precise value. And that's one way to get centimeter level accuracy. With Pyka and a lot of, I think, like if you're spraying a crop, of course, you need to know exactly where you are in real time. It doesn't matter after the fact.
Right.
And so I think RTK is a more common solution, especially because you don't need to rely on a third party to process your data. And it's gotten much more accessible in the last couple of years. And so I'd love to talk about the ways that you can get RTK on your drone right now for not too much money.
That was my next question: is what is needed? How do you get there?
First of all, you need a GPS receiver that is capable of processing, these RTK corrections. So I think the most common one that I've seen now is manufactured by U-Blox. It's the ZF9P, so the ZED F9P, and you see that kind of popping up everywhere. So, I'm not sure for a lot of the commercial kind of off-the-shelf drones how many of them specify which receiver is being used, but generally they will say if they're capable of RTK or not. The cool thing is that these receivers are doing all the corrections on board. Like, you just need to feed them this correction data, which we can talk about, and they do all the calculations. And that wasn't the case, 3 years ago, 5 years ago. So that's what's so exciting now. It's like you don't even really need to know how it works. You just need to know what you need to give the receiver, and it'll take care of everything.
Okay. And so you mentioned, feeding the collection data. I mean, is that something that's easy to do, or do you need some know-how?
It's not terribly complicated. It's kind of one of those things, I think, that you're going to kind of iterate on your level of understanding. First you'll read about it and be like, oh, I think I kind of get it. And then you'll be like, actually, I don't understand about 90% of it. But like the more you just kind of read some articles, SparkFun has a really great kind of tutorial about how to set up a base station to get RTK corrections. It still feels like magic to me, but I feel like I know a couple of the spells, and that's really all you need to get the benefits of it. Yeah, so essentially, if you want RTK, what you need is some sort of base station that is going to publish corrections. And these corrections are in the form of RTCM messages. So there's a handful of messages that will go from a base station to your rover. So those are kind of like the two terminologies we'll use. Like, the base is a fixed receiver, and the rover is whatever's moving around on your drone. And the base station is this at a known position. So there are a number of ways you can do this. You can either there are many base stations that are set up either like as a government, there'll be like government organizations or research organizations that have their own base stations because they need the corrections and they're publishing them. Or you can set up your own. It's really easy. If you just have a second GPS receiver, you can record data for a certain amount of time. I mean, even a few hours will get you close enough. And so collecting that data over a long period of time, you're able to post-process that data. There's a couple organizations that will do that. You want to know where your base station is within, let's say, a couple centimeters. Basically, whatever accuracy you have with your base station, you should be able to get that with your drone. And so the idea being that if your base station knows exactly where it is, and you will tell the receiver, either you can post-process it, exactly where it is, or the U-Blox receivers have a mode called survey in, where they know that they're supposed to be a base station. They'll try to estimate their accuracy to a certain threshold. As soon as they know that, they lock in and say, okay, here's where I am in space. Therefore, any basically, if any GPS signals that I get that tell me that I'm somewhere else, I know that that's an error, or I can assume that's an error. So they're able to calculate these corrections from each satellite, because they say, I know where I am. You're trying to tell me that I'm a little bit over here, but I'm not. So that must be from the errors that we've, have come through the atmosphere. So that's how they calculate, and they'll produce these RTCM messages. You want your base station, the antenna should have, you want it to have good view of the sky. It should be basically, any errors that are in your base station will be propagated to your rover. So if you don't have a great base station solution, like, you're just going to see that error is propagated. If you used the survey in mode, so that's if, let's say I go to somewhere, I'm flying somewhere new and I'm just going to be there for the day, but I do want to
Mhm.
have centimeter level accuracy while I'm there. So you'd use that survey in mode. You'd set up. So I use like a tripod for my antenna. So it's in a fixed spot. I let it run for. It takes. A matter of minutes if you've got a good view of the sky with a nice antenna, and it basically it will fix its position. You won't have absolute centimeter level accuracy from that
Mhm.
from that base station, but you'll have like relative centimeter level accuracy. So because like we said, the base station will only know where it is within a couple meters. It's still got all the inherent GPS inaccuracies because again it's got that centimeter level accuracy, just not in the absolute sense. So this
Okay.
might not be great if you're trying to map something. Like, if you're getting a 3D scan, you really need that absolute accuracy. If I want to say, I want to locate something on a map, I want to know exactly where it is in 3D space. The survey in mode might not be sufficient. But if you just want to have your vehicle performing much better than it might normally, like if you want to have your drone hovering perfectly in place, uh, then that relative accuracy would be sufficient. At Pyka, we do, we're flying at airfields. We know we're going to be there for a long time. So like the first thing we do when we go to a new spot is we will get a fixed base station location. And then we just set that. And every time we fly, it knows exactly where it is. There's no, you don't have to do that every time.
Where would somebody find like a base station? How can you get one? And or even the antennas? Are those just things that you acquire online from certain sites?
Yeah. So, SparkFun's a great place to look. There's a company called Arju Simple that's in Europe. We can link to that. They've got a lot of great tutorials. And a lot of their products are intended for. It's basically just to get RTK more accessible. It's extremely affordable. These receivers are on the order of a couple $100s, which is just an order of magnitude less than I think it cost 5 years ago to get RTK. The nice thing is your base station could be the same exact receiver that you have in your rover, which makes things really easy. So you're only familiar with, you only need to be familiar with one GPS receiver. And uBlocks has software to configure them. Again, there are many tutorials. Like RG Simple has configuration files that you can just download. And you say, okay, I want to make one of these receivers my base and one my rover, and they've got configuration files ready that you just use the software to upload directly. So like you could really hardly know anything about it and get a solution working. The key is that you need some way of transmitting the corrections from your base to your rover. So
Okay.
I think probably the easiest way is just a point-to-point link. So like an XB radio or something. In RG Simple, they have basically all their kits have headers you can just slap on an XB radio. They sell kits that are ready to go. You could just one-stop shop. They'll sell you the base and the rover with the XBs configured to talk to each other. So it's practically plug and play. For under $1,000, you can have RTK out of the box, which it's just, it seems crazy to me. It's
Yeah,
fantastic.
that's so much more accessible than I would ever imagined. And so that's really cool. Do you think it's only going to become more accessible into the future as things continue to develop?
I don't see why not. I think as the receivers get cheaper, and as more people buy them and it becomes more popular. So yeah, go out there and buy some so the prices come down so we can all get the benefits. If you don't want to have a base station, you can leverage one of these existing ones. RTK to go is a great site that works with that. Basically, it shows you they're called casters. So it's essentially like a fixed base station that is publishing data to a server, and then you can use, if you have internet access, you can then retrieve those corrections. The catch is that you have to be within roughly 35 kilometers, I think is kind of the number I see. With you have to be near enough that caster so that the corrections will still apply to your rover. But there's a number of free ways to just get correction data if you didn't want to have your
Oh,
base
wow.
station.
Wow. Again, accessibility. I'm just so surprised that that this is anyone can really do this.
It's wild. It's so cool.
Well, Greg, thank you so much for coming on and explaining this to me. I really appreciate it. To our audience, you can submit your own drone questions at ydqa.io. I'll do my best to find the answer to it, or again, find the person who can answer to it. In the meantime, though, we'll see you in the sky.